Imagine yourself in a cocktail party. You're in the middle of a busy crowd. All the guests' voices are merged together. How would you be able to isolate each person's conversation from this auditory mess? What I've described to you is an instance of a general problem called tensor decomposition. This is a picture of a three-dimensional tensor on the top right, a higher dimensional analog of a matrix. And its entries all store these auditory signals together. Tensor decomposition is the problem of approximating this tensor by rank 1 tensors. In other words, a tensor product of three vectors, A, B, and C. Tensor decomposition is the multilinear analog of a singular value decomposition, or SVD, for matrices, shown in the top left, which is a method of approximating a matrix as an outer product of two vectors, A-B transpose. And as many of you know, SVD is the workhorse of principal component analysis, or PCA, for high-dimensional data. Now, just like matrices have singular vectors, tensors also have singular vectors. And these are the vectors which provide the best rank 1 approximation. In my research, I discovered a link between singular vectors of matrices and tensors and quiver representations, shown in the bottom left. A quiver representation is just a directed graph where you place a vector space on a vertex and a linear map on each edge. And just like we can just like we have singular vectors for matrices and tensors, we can now also talk about singular vectors of quiver representations. So these are assignments of vectors to each vertex, such that whenever you pass them through each edge from the source to the target vertex, you have to get a scalar multiple of the vector at the target vertex, exactly like a singular vector. And quiver representations are very important in many areas, such as representation theory and also topological data analysis. So what I'm now exploring is a hypergraph analog of a quiver representation called a hyperquiver, which looks like this. So just like singular vectors of a quiver, like this one, is a pictorial representation of a rank 1 SVD of a matrix, this hyperquiver is a pictorial representation of a rank 1 approximation of a tensor. And this new theory of quiver representations is a lot to be explored, and it can be made very general. There's nothing stopping you from drawing any crazy hyperquiver you want. And I'm using algebraic geometry in my research to study the space of singular vectors and therefore tensor decomposition.